So as I just mentioned, so basically, and if you want to caller to pass some information to callee, they need to put their argument into the register A0 to A3. If the callee want to return some value to the caller, they need to store that return value to the register V0 and V1. So here actually implies some limitation. The limitation is the arguments can be passed only need up to 4, right? And each argument's data cannot have the size larger than 32 bits. Similarly, if you want to return the value from the callee to caller, you're only allowed to return up to 2 data. Each data cannot have size larger than 32 bits. So this actually does not apply to some practical situation. So potentially you want to pass argument more than 4, or you want to return the value more than 2, or the individual argument is larger than 32 bits, or individual return value data larger than 32 bits. So in that case, what you can do? I want you to pause here and think a little bit. What you can do is, how about we not only rely on this kind of small storage place hardwired in the processor, which called the general purpose register. How about I leverage also the larger storage place in memory? In other words, I store some of the data potentially need to pass through those kind of general purpose register into the memory. And the memory has a large one-dimensional array. So which section of the memory? The section is called the stack. So basically, what I do here is I try to store some value from the register, which is the A0 to A3 or V0 to V1, to the memory. And the place to store those data is called stack. So because stack is a one segment from the memory, it will share the same property of the memory, which is byte addressed, also one-dimensional array. And when you push the data into, they will follow the queue called first in and first out. In other words, if that data is push that at last will pop up first. So again, if you want to push the data into stack, into a big memory place, you have to make sure you can later find that in appropriate place, or originally you will store in appropriate place. So basically you need to have some information point to you or help you to find where the original store that data is, or where I should store the data to. And one more time, what you mean is I need some information, tell me the address of the place in where I can store my data or I can find my data. That the information associated with address about the in the stack is called the stack pointer. That is actually another general purpose register. It's a system level. That is the one we just mentioned before. As I will talk very soon, the stack pointer. If it's in index 29, all the purpose is to point to the appropriate address in the stack. Or say point to the lowest, the bottom or the boundary of the stack. So why I say that, basically the stack will be like this way, one dimensional array, and then originally their boundary is very high. So basically initialize as the highest place. Here is where the stack pointer point to. So at this time, the stack is still empty. After that, when you want to store some data into the stack, before you store, the first thing is you need to move the stack pointer from the top to bottom at a certain place, okay, to give you enough space to store whatever data you want to store. So let me say one more time. Your stack pointer always point to the bottom of your stack. And when the stack is empty, the stack pointer is initialized in the highest place. When you want to store the data from the register into the stack, the first thing you need to do is adjust the location of the stack pointer to make sure you have enough space in the stack to store the data whatever you want to stay. So that means the stack pointer value is moved from top to down. So my question is, just as I just give you some hint, I already tell the stack is one part of the memory, therefore it's a one-dimensional array, it's a byte address. So my question is, if I want to store one data, basically it's a 32-bit data from the register to the stack. My question is, how, if your original has a stack pointer here, how many space you need to move down? I wanted to pause here to think. If I original stack pointer point to here, so now I want to store the data 32-bit from register to the stack. So how much, or what is the shift? What is the amount of shift you need to realize or implement on the stack pointer in order to give me enough place to store this one word? I want to pause here to think about it. And that will be 4, right? So basically, updated stack pointer value will be stack pointer minus 4, which will point here. Because again, stack is a part of the memory, so it's also byte addressed. So each location, each spot is only 1 byte, which is 8 bits. So in order to store one word, I need 4 spots emptied. Therefore, I need to shift the stack pointer from the original stack pointer to the stack pointer minus 4. So that is very important. This is also always need to rely before you store anything into. Here, I also want to give you a term called spilling register. I think we mentioned that before. So spilling register means if you want to store some data from the register to the memory. Okay. So another thing is there's another two words always used related to the stack minus push. Basically, if you store the data from the register to the stack, we call push into. If you want to load the data from the stack to the register, that's called pop off. Okay, we said the last one push into, the first one pop out. The reason is, you can see here, right? So after you adjust, okay, now I want to pop out. What I do is I adjust my stack pointer back to the upper location. So in that way, the last one push into will be the first one pop off. Okay, so here is a give a more general idea. So basically, your stack pointer initialize in the highest place, and then you will move down in order to give you enough space to store the data. When you move down, basically your value in the stack actually adjusts by minus times of 4. You move once, you move to the give the enough space to store 1 data will be minus 4. You store 2 data, you need minus 8. 3 data, you will minus 12. Similarly, after you remove that the data originally stored in stack, you need to adjust your stack pointer back. So if you want to pop 1 data off, you will be 1 word off. So that will be adjusted by stack pointer plus 4. You will pump 2 words off with stack pointer plus 8, and so on. Okay. So here, give a more straightforward idea. So here, basically, I have a procedure A, and then in the procedure A, I call procedure B, and in the procedure B, I call procedure C. Okay, so in that way, when I implement procedure A, basically, if I need to store some data from the register to the stack, what I do is I need to shift the stack pointer to a lower place to give you enough place to store the words belonging to procedure A only. And then I begin to implement procedure B, so I need to continue give enough place in the stack, basically keep adjusting the stack pointer to lower place to give enough space to store the variable belonging to procedure B. Similarly, when procedure B call the procedure C, I continue to adjust the stack pointer to the lower place in order to give you enough room to store the variable associated with the procedure C. When the procedure C finished, what they do is I will adjust the stack pointer to the higher place in order to release all this original location or segment in stack to store the variable to C to be free. In other words, I will not remove the data in here. The only thing I do is adjust the stack pointer to the higher place, and anyone else can use this space. This basically is equivalent to remove that place. Similarly, when I finish implement the procedure B, I will adjust my stack pointer to the higher place and then release this space for free. If procedure A also finished, this whole stack will be emptied. Okay, so now I already talked about stack pointer. Basic stack pointer is a general purpose register provide you the location or the address in the stack, which is the bottom of the stack. And also, we actually has another system-wise or the global register, which called frame pointer. The frame pointer, instead of point to the bottom of the stack, it point to the top of the stack. So you might ask, I already have the stack pointer, why I need a frame pointer? The reason is your stack pointer keep adjust up and down during the procedure implementation based on whether you have some data you need to push into or you pop off. However, the frame pointer is a stay still throughout the whole procedure. So basically, this provide a more stable baseline for your stack place. So here, this diagram shows, so basically, originally, your stack is emptied. There's no data stored into. Therefore, the stack pointer point to the top, and the frame pointer point top, stack pointer point bottom. And then when there's some data need to push into, what they do is frame pointer will point to the original place of the stack pointer, and the stack pointer will adjust up and down based on whether there's some data push into or pop off. But the frame pointer will stay still through the whole procedure. And then after everything finished, this part emptied, all the data pop off, or say all the data will be set free. All the space will be set to be free. Then the stack pointer and the frame pointer will point to the original place. Again, the frame pointer is not to be used that often in our class, but only in our class, from our class perspective. But this is important because it provides a stable base register for your whole procedure. So here is another way to describe, right? Before the procedure call, there will one point top, one point bottom, and during the procedure call, you will adjust your frame pointer, and then make sure your frame pointer is point to the stable place. And then after finish, it will go back to the original. So another thing I want to talk about the memory layout. So we already say the stack is basically is one segment in the memory. Actually, in the memory, it's not only have stack. Basically, it has 4 layers. One called the reserved segment, second called text segment, and then called the static segment, and then it's a dynamic and stack segment. Again, the reserved segment is store all the operating system text into there. That is not can be used by any potential implementation. That is already reserved for the operating system. And then the text, this segment is used to store all the potential instructions, the machine code, the associated instruction, all those instruction code. And then the static data is used to store those global variables. And then the dynamic data and the dynamic segment and the stack is kind of can be adjust to each other and used to realize the the heap or the dynamic storage place. Again, those segments are already predetermined, but the dynamic and the stack can potentially increase or reduce to each other in order to fully advantage or take a fully advantage of this place. So here we already mentioned those individual registers. So maybe today we stop here. In the beginning of next class, we will talk about this leaf procedure. Okay, this example. Thank you.